Okay, so here we are on Stats and Mechanics Year 1, Chapter 9, Mixed Exercise, Question 12. Okay, a pebble is projected vertically upwards with a speed of 21 meters a second. So we start going upwards at 21 meters a second. Okay, from a point 32 meters above the ground. So we are here and we are 32 meters up. Okay, above the ground. Find the speed with which the pebble hits the ground. So not a lot of information to start with, but what can we infer? So this will come up to here and then it will continue on down to here. Okay, and in that blue arrow and that green arrow, everything's the same, just reversed. Okay, and then we've also got the final part of the pebble going up and over for this thing as it goes up and down and hits the ground. Okay, we end up with the red arrow there. And so the first thing they want to know is they want to know the speed at this point here. So we do have an acceleration, not given. Okay, so we've got an acceleration of 9.8 meters a second. Okay, now that is the direction that I am going to consider to be positive. Okay, so positive this direction is negative. So just so that I get all of my signs correct. So let's see if we can do suvat on the red arrow. Okay, so our acceleration is 9.8 as said because of gravity. I don't know my time. My final velocity I don't know. My initial velocity I do know. It's going to be 21 meters a second because by the time the stone flies up and comes back down, it will have accelerated back to 21 meters a second by the time it passes here, and my distance is 32 meters for this one. Okay, so I want final velocity. I'm looking for the equation without time, so I've got v squared equals u squared plus 2as. So v is equal to the square root of 21 squared plus 2 times 9.8 times 32, which is all under the square root. Okay, so 21 squared plus 2 times 9.8 times 32 is nothing particularly nice, 1068.2. Square root of 1068.2. Square root of that is really nothing nice, 32.68. Okay, 32.68 meters a second minus 1. Done. Right, part B. The total time for which the pebble is more than 40 meters above the ground. Okay, so let's have a little look. We are looking for a distance here, which is going to be 40 meters above the ground. Okay, so we could go between here and here. Now this is obviously 8 meters in here. Okay, let's make some choices here. We can either try and find, I think what we'll do is we'll find the section that goes from here to here, but we first need to break this 21 meters a second down. How slow have we got after that first 8 meters? So if I consider this part of the stone throw here and put up suvat for that, my distance is 8 meters going from 32 up to 40. Okay, my initial speed was 21, my final velocity I don't know. Okay, my acceleration is 9.8. Now incidentally, my initial velocity was minus 21. Okay, and my time I don't know. Okay, so if I do that, if I use that, I can then set up a, let's do it in, need another color, not that color. Let's do it in orange. So I am now looking for a suvat of this here. Okay, so I don't know the distance up to the top. The initial speed will be the final speed of the purple. Okay, my final speed will be 0. My acceleration will be 9.8, and my time I don't know. Okay, I don't know. But by using this purple suvat, I can find that final velocity, which then can lead into this orange suvat and then give me the time. Okay, so what's the no time equation? It's the v squared, I'm running out of space here. Right, in the purple, we use the v squared equals u squared plus 2as. Okay, and so we will find it again being square root of minus 21 squared plus 2 times acceleration 9.8 times 8. Okay, and so v is equal to, so 21 squared, 441, plus 2 times 9.8 times 8. Okay, 597, and the square root of that is 24. That doesn't make a lot of sense. All right, so distance is minus 8. Sorry, distance is minus 8 because I'm traveling upwards. All right, so there we are. So when we put that into here, okay, we end up with 21 squared, okay, plus 2 times 9.8 times minus 8. Okay, and the square root of that, not the square root of that, is 16.85. So remember, I decided at the beginning that I was going to have negative up here, so this is a negative 8 distance that I have travelled. Okay, to allow the signs to come out correctly and make it drop down. Otherwise, it has accelerated downwards for the first 8 meters of the red arrow. Okay, so with that done, I can now use this orange suvat and substitute in my 16.85 into here. Okay, and I'm looking for the time on this one. Now that's a minus 16.8 because I'm still traveling in that direction. I'm looking for, was it time? Total time, which will be doubled in a minute. So I'm looking for the no S equation. So using my orange pen, I'm going to be using V equals U plus AT. Final velocity of 0 is equal to a minus 16.85 plus a 9.8 t. Okay, so 16.85 divided by 9.8 should give me the time, divided by 9.8, which gives me 1.72 seconds. Remember though that that is only the time on that orange one there. To get to the top, I also have to travel back down, and so the time taken will be double that. So t above 40 meters is equal to 1.72 times 2. Okay, 3.44 seconds. Okay, so 3.44 seconds on that. Brilliant. Last bit, sketch a velocity time graph for the motion of the pebble from the instant it is projected to the instant it hits the ground, showing the values of t at any point where the graph intercepts the horizontal axis. Okay, so what is draw a graph? Now then, this graph has got some positive and negative velocities on it. So there we are. So I have said that we're actually starting at minus 21 meters a second. Okay. Is that possible? I suppose it is. It doesn't really matter. Right then, so if we start at minus 21 meters a second, so here's velocity, and we're in meters a second, and we've got minus 21 down here. When the velocity is 0, that is the moment that we hit it, and we have been traveling at 9.8, and then it just continues getting faster and faster and faster until we hit the ground. Okay. Well, it's just going to be a constant acceleration, so it's just going to look something like this. Okay. What do they want to know? Sketch the velocity time graph for the motion of the pebble from the instant it's projected to the instant it hits the ground, showing the values of t at any point where the graph intercepts the horizontal axis. So we could do with having knowing t here and t here. This is time, by the way, in seconds. So what do we know so far? We know the final velocity of 32.68. So this one up here is 32.68. Okay. What's all the time working out? I haven't worked out the times on anything except for that one. Okay, fair enough. So how long is it going to take for the time between here and here? So that's just using this SUVAT 32, but no, it's not. It's using the blue one over here. It's one we haven't done yet. So we need to do a SUVAT for this bit here, i.e. the orange and the purple combined. Okay, so that didn't move it. So let's quickly do that. So the distance I don't know, I don't care about. The initial velocity was minus 21. The final velocity is 0. The acceleration is 9.8. And the time is what I am looking for. So what's that? No S again. V equals U plus AT. So 0 equals minus 21 plus 9.8 T. So 21 divided by 9.8 basically. All right. 9.8 is equal to time. 21 divided by 9.8. 2.14. So that is 2.14 seconds to there, and then we can quickly do a suvat for the final drop between here and here, okay, which we know the distance we don't know. The initial speed was 0. The final speed was 32.68. The acceleration was 9.8, and the time is what we are looking for. We don't know. Okay, so again, I can use the V equals U plus AT, but this time 32.66 is equal to 0 plus 9.8 T, and 32.66 divided by 9.8 gives us 3.33 seconds is equal to time, but of course we have already traveled for 2.14 seconds, so we have taken 5.47 seconds to get there. Okay.